Today we continue with subgraph and trees. A subgraph of a graph GVE. G is the symbol for graph, V is for vertices, and E is for edges. It's a graph such that its vertex set is a subset of the set V. Its edge set is a subset of set E. So a subgraph of a graph G is a part of graph G including the graph itself. So what does this mean? So here we have an example. A subgraph of graph G is obtained when a few of its edges and or vertices together with all the edges connecting the vertices are removed from the graph. Okay, remove. For example, so for this graph G we have P, Q, R, S, T. Okay, and then this is the edge. So for subgraph, we can remove any vertices and any edges from this graph. 你就从这里 P, Q, R, S, T， 你可以拿走任何一个点，或者你拿走任何这些线，就是等于它的 subgraph 了。Okay, so the subgraph of this graph G will be this one. So a few examples of the subgraph of graph G. So number one, HRS is removed. Okay, so this one, what's the difference between this one and the graph G? So for graph number one there, we remove the HRS. 我们把这条线去掉。Okay, so this becomes the subgraph of graph G. The rest still remain the same. Okay, we still have P, Q, R, S, T, and then these edges are still the same, but we just remove this RS. So this is an example of subgraph. Okay, number two. So this is another example of subgraph of graph G. For this, we remove the vertex S. Okay, so you see how we only have P, Q, R, T, but we remove the S here. Okay, we remove S here. So these two lines also disappear. 你把 S 拿掉，然后这两条线也不见了。So we're left with P, Q, R, T, and then this 1, 2, 3, 4, 5 lines here. Okay, so this is another example of subgraph. Number 3, the vertex T and H, P, Q are removed. Okay, for this one we remove T. Okay, we remove T, and also all lines connecting to T also disappear. And we also remove this H, P, Q. Okay, so this is another example of subgraph. Number 4. Okay, for this one, P, Q, R, S, T all there, and then all edges are also there. So this one is same with the graph G. Okay, same with this. And this is also a subgraph for graph G. And of course, we still have many more examples for subgraph. We can remove Q, we can remove R, we can remove P, and so on. So this is the meaning of subgraph. A tree is a graph with the following characteristic. Okay, a tree is a simple graph. Simple graph means no loops and no multiple edges. Okay, no loops like this, and then multiple edges mean two lines connecting two vertices. So no. So a tree is just a simple graph. All its vertices are connected, as is a path between any two vertices. So all vertices must be connected. 每一个点都要把它连起来。Each pair of vertices is connected by one edge only. This is called acyclic. Number of edges equals to number of vertices minus 1. Okay, so this is very important for trees. This relationship can be used to identify trees. So for trees, number of edges equals to number of vertices minus 1. Okay, for example, this is a tree. Okay, how do I know that this is a tree? Okay, you have to identify whether it fulfills all these 4 characteristics. Number 1, this is a simple graph, no loops, no multiple edges. Okay, so no loops, no multiple edges, yes. Number 2, all its vertices are connected. Yes, all vertices are connected. Number 3, each pair of vertices is connected by one edge only. So vertices are connected by one edge. Yes. Number 3, number of edges equals to number of vertices minus 1. Okay, so this is very important. So how many number of edges in this tree? 1, 2, 3, 4, 5, 6, 7. So number of edges equals to 7. Edges, you calculate how many lines in this graph. 1, 2, 3, 4, 5, 6, 7. 7 lines. And number of vertices, how many black dots here? So 1, 2, 3, 4, 5, 6, 7, 8. So we are using this formula. Number of edges equals to number of vertices minus 1. So number of vertices with minus 1. So 8 minus 1 equals to 7. So this is equals to number of edges. So yes, this is a tree. 这是非常重要的一个啊，你一定要检查它的 number of edges， 它这条线，还有它的 number of vertices， 它这个黑色的点。OK， 它们之间要有什么关系？就是这个线是等于线的数量啊，等于这个黑点的数量减1。如果它有完成这个条件的话，那么它就是一个 tree。Okay, example, not a tree. Okay, so this one. Isolated vertex, red dot, not connected to the other vertices. So these two vertex are not connected to other vertices. So this is not a tree. And this one, why this is not a tree? Okay, we calculate number of edges. So 1, 2, 3, 4, 5, 6, 7, 8. Number of edges equals to 8 lines here. And then number of vertices 1, 2, 3, 4, 5, 6, 7, 8 also. So number of edges must be number of vertices minus 1, which is 8 minus 1, 7. But this one we have 8 edges, so this is not a tree. It does not fulfill this formula. 你看这个点它有8个，然后线也是有8个，它就不符合这一个条件。因为这个条件是讲线一定要等于点的数量减1，所以点的数量有8个，8减1，你的线应该只能够有7条了，可是这边有8条，所以这个不是一个 tree。Trees are usually used to determine the shortest path with the condition the path passes through each vertex once only. Let's look at the example. The diagram shows 4 graphs. So we have graph G, graph G1, graph G2, and graph G3. Determine whether graph G1, G2, and G3 are the subgraph of graph G. Okay, determine whether they are subgraph of graph G. So for graph G1, you just compare G1 with G. So P, P, Q, Q, R, R, S, S. Okay, so this one we have E1, E1. Yes, it's the same. E2, E2 is the same. And this is E7, E7. Yes. E3, E3. Okay, so this graph G1 is a subgraph of G. Just that we remove T and also E6, E5, E4. But still this one is a subgraph.OK， 你看这个它是不是它的 subgraph？ 你就看它的点 PQRS 都一样的，位置都是一样的。然后这是1是对，1一样，13一样，17一样。只不过我们把这个 T 去掉，然后16、15、14也去掉。可是这个是它的一部分，所以它是对的，它是一个 subgraph。So graph G1 is a part of graph G. So G1 is a subgraph of G. Then how about G2? Is G2 a subgraph for graph G?Okay, we check. So P, P, yes, Q, Q, S, S, T, T. Okay, all the positions are correct. And then E1, yes. Okay, this is E7, but here we have E2. So this is wrong. Okay, this one's supposed to be E7. E4, yes. Okay, this is E5, not E3. So this one's supposed to be E5. So this graph G2 is not a subgraph for graph G. Okay, because these two are different. E2 and E3.Is supposed to be E7 and E5. So graph G2 is not a subgraph. Graph G3, okay, PQRST, PQRST, yes. E1, E1, E2, E2, E3, E3, E4, E5, E6, E7. Okay, so graph G3 is also a subgraph for graph G. We do not remove any vertices, any edges, but it's still a subgraph of graph G. So only G1 and G3 are the subgraph for graph G. Example 15. Draw a tree based on the given information. Add vertices. Okay, so this one we have number of vertices equals to 8. Okay, for a tree, there's a very important criteria. There is number of edges must be equals to number of vertices minus 1. So how many edges do we need to draw?So number of vertices, we have 8. So 8 minus 1. So we only can draw 7 edges. Okay, so how to draw out the tree? 8 vertices. So we draw out 8 black dots first. And then you draw 7 edges. Okay, for this one, you can also draw like this. 8 vertices. So we draw 8 black dots. And then you draw 7 edges connecting this 8 dots.And this one we can also call it a tree. Then B, 5 edges. So 5 edges mean that we have 6 vertices. Okay, because 5 equals equals to number of vertices minus 1. So black dots must be 5 plus 1, 6. Okay, so you draw out 6 vertices and then you draw 5 edges. Okay, you can also draw like this, 6 black dots. Then you draw 5 vertices. Okay, this is also a tree. Example 16. Draw 2 trees based on each of the following graph. Okay, so for graph A, we have 1, 2, 3, 4. Number of vertices equals to 4. And then number of edges, we have 1, 2, 3, 4, 5, 5. But for trees, number of edges must be equals to number of vertices minus 1. So vertices we cannot change already. Vertices we have 4, so 4 minus 1, number of edges must be 3. Okay, so how to draw a tree? So these 4 vertices must remain 1, 2, 3, 4. We just draw any 3 edges. So let's say we remain this one, 1, 2, 3. So 1, 2, 3. So this become a tree. And then for this one, okay, we have to remain these 4 dots. And then for edges, you can draw 1, 2, 3. Okay, as long as we connect these 4 dots. So this is a tree. Okay, for B, number of vertices, we have 1, 2, 3, 4, 5, 5 vertices. So number of edges, for 3, it must be 5 minus 1 equals to 4. But here we have 7 edges, so we have to remove 3 edges. So it still remain the same. These 5 dots, then you draw out 4 edges connecting these 5 dots. C, we have 1, 2, 3, 4, 5, 6, 6 vertices. And we have 1, 2, 3, 4, 5, 6, 7, 7 edges. We have 6 vertices, 7 edges, but for a tree, we can only have 6 minus 1. Okay, number of vertices minus 1, so we can only have 5. So and 6 by 2 edges. So you just remove any 2 edges from this graph. Okay, so you can draw like this or like this. Example 17. The diagram shows a graph. Draw a subgraph of the graph that satisfies each condition below. A subgraph with 5 vertices and 5 edges. So this graph we have 1, 2, 3, 4, 5, 6. 6 vertex. And 1, 2, 3, 4, 5, 6, 7. 7 edges. Okay, we have 6 vertex, 7 edges. Question wants us to draw a subgraph with 5 vertices and 5 edges. That means we have to remove 1 vertices and also 2 edges. So which vertices should we remove? Let's say if I remove this P. If I remove this P, I can only remove 1 edge. Then this will become 1, 2, 3, 4, 5, 5 vertices and 1, 2, 3, 4, 5, 6, 6 edges. So we cannot remove P. Okay, I repeat. So if I remove P, then I left with Q, U, R, T, S. Okay, so I have this one, this. Okay, I only remove P, so left with 5 vertices, but with 1, 2, 3, 4, 5, 6, 6 edges. So this is not as required as the questions. So the questions wants 5 vertices and 5 edges. We have to remove vertex Q. Okay, so if we remove vertex Q, then these 2 lines also disappear. So we left with 1, 2, 3, 4, 5. 5 edges, 5 vertices. Okay, let's say if you want to remove vertices R, then what will happen? Okay, if we remove vertex R, then 1, 2, 3. These 3 lines will disappear. So we left with 1, 2, 3, 4, 4 edges. So we also cannot remove vertex R. So we can only remove vertex Q. Okay, you can try. If we remove U, what will happen? If we remove T, what will happen? If we remove S, what will happen? Okay, B, a subgraph with 6 vertices and it is also a tree. Okay, so for this one, we remove the edges Q, R, and TU. Okay, we remove Q, R, and TU. And you have this one. This is a tree.